Hello and welcome to another video on ChatGPT prompt engineering for developers. So what I'm doing right now is, keep track my progress using the project template from Notion, which is actually kind of cool. You can also see is your progress among that. So I dedicate is time to first set up the timeline for this course up to it seems it doesn't show me up to when up to so far it doesn't up yet it show me that until May 19th, right? So we begin this course in May 8th. So far today is um, 15, so Monday 15. So we got a couple days to wrap this course. Okay, so we also is following is the Scrum framework from the Agile Manifesto, which is a software development uh, project management. So yeah, and this is the couple tasks that I defined, right? First, the introduction. So understand is the course details. So when you navigate to the deep learning course, the URL link is this ChatGPT prompt engineering for developers. All right. So these course details that we have here is that they're gonna show you how to use LLM, this large language model, and build uh, quickly new applications using the OpenAI APIs and to see how quickly you can develop new capabilities that adapt to innovate and provide values in ways that were traditional, cost prohibitive, highly technical, or impossible before now. So this course describe how LLM works, good prompting engineering, meaning how to write efficient and effective prompt, as well as how to use LLM APIs that can be used in your application for a variety of tasks, such as summarizing the user review for brevity, transforming like translation, spelling and grammar corrections, inferring sentiment classifications or topic extractions, and expanding, automatically writing emails. And we're also going to look here is at the couple principles needed for interact with this LLM, as well as how you can write effective prompt and how you can do that systematically and ultimately build a chat application for that. So all of these concepts are illustrated using is the Jupyter Notebook environment. So the only requirement here is that you should know or that you have basic understanding of Python. So when I start this, okay, in this introduction, Andrew and G mentioned that even though there's several best practice out there, like 30 articles or like articles like 30 things that 30, 30 things that everybody should have uh, uh, yeah, like you might find articles out there like 30 uh, 30 things that everybody has to know. Uh, and most of those best practices are focused on the ChatGPT web interface, which is what most people use often for one-off tasks. But again, Andrew and G mentioned that the power of this is for developers that they can, and this LLM allow when you interact with this API to build software much more quickly. And the using is the AI Fund, which is a sister company from the deep learning, to do that, right? So in the development of this LLM, we have broadly two types. The base LLMs, which predict the next word using training data. So for example, if you prompt something like there was upon a time with there was upon a time a magical unicorn, and the prompt I would likely to reply with that live in a magical forest with all her magical unicorn friends. So when you ask, for example, what is the capital of France, we will likely to complete with what is the French population, what is the French most populated city, what is the currency of France, because the articles that were fit with this base LLM are highly likely to have a list of quiz are highly likely to have a list of quiz to uh, about the country of France. So because these base LLMs are trained from different sources and also from the internet, this is one way that they or one possible way that they can complete that, right? But in contrast with this instruction to an LLM, which attempts to follow instruction, uh, the way it works, for example, if you prompt now what is the capital of France, it will likely to complete with the capital of France is Paris. So the way how this instruction to LLM works is because now they start using a base LLM with a huge amount of data, and then further training to turn in providing inputs and outputs that attempts to follow instructions, and further with further techniques like the reinforcement 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 learning, okay, and practice also my English here. So reinforcement learning with human feedback. And this is to make the system much more helpful. And also, the developers uh, train this model to be helpful, harmless, and honest. So you are less likely to get some toxic output or problematic. And you can think of this LLM as a smart person that doesn't know the details. And it is helpful to provide the context for that. So if you're going to ask about Alan Turing, so it will helpful to provide the context about what their personal life, his scientific works, the role about history, or something else, as well as the tonality. So give me this as a professional journalist or something more casual. So then I look at the guidelines like this, okay, which are pretty straightforward. Here we're using is the Jupyter Notebook to see how it works, how it does that. And these guidelines, uh, again, it is using is the Open AI API, and underneath the hood, it's using is the GP3 GPT 3.0 Turbo LLM model. So the first principle for writing effective prompt is be clear about be clear, about the mhm. So be clear. Uh, the first principle, Jesus. The first principle is write clear and specific instructions, as well as set of tactics to help us. So here, the set of tactics for the principle one is define delimiters to distinguish different part of your input. This is also to prevent uh, prompt injections. Okay, so for example, some smart ass tried to override the previous instructions, so you delimited that so the model can recognize that. And you can use triple backticks, triple dash, uh, ankle brackets, uh, yeah, like this. So when I look at this, I'll pass through this. At first, it'll be a high-level principle, and then the specific tag to example, and we'll use it. No, this is part of the guideline. Exactly. So use the limiter for that. So you can use this triple quotes, triple backticks, triple dash, angle brackets, or XML tags as well. The second tactic is to ask for structured data like JSON or HTML. The third tactic is to check whether the conditions are satisfied and check assumptions required to do the task. And the fourth tactic is few shot prompting, meaning give the model uh, successful examples to complete a task and then let the model perform that. So this is the four tactics here for the principle one. Okay, and then I look at the principle two, that is give the model time to think. Okay, so for example, if your model is outputting incorrect answers, so try to reframe that with a series of step or change of reasoning before let the model provide its final answers. So another way to think of that is much like when you ask a human to perform a complex math questions without time to work the answer first, they will also likely to make mistakes. So this is much like what happened here when you provide too complex instructions to do it within a short amount of time. So the model, they end up making guesses which are likely to be incorrect. So in these situations, you can instruct the model to think about the problem, which means is that tactic one, specify the step to complete a task, and the tactic two is that instruct the model to work out its own solutions before rushing to a conclusion. Okay, so for example, when you provide a set of example and a student exercise and their results, so instead of copy and paste that on the model and see uh, and expect if the answer provided by the student is good or bad, is right or wrong. So, well, instruct the model to work out its own solution before rushing to a conclusion. So let indicate the model to pass and evaluate the problem, figuring out its own results, and then compare that with the result made or compare that with the solution provided by the and compare that with the solution provided by the student to see if that actually if to see if you have the same result or different. Okay, so this is all about the guidelines, right? So far, very, very understandable, you know. Guideline. So the principle one is write clear and specific prompts. Okay, so short prompts are different from clear, and the several tactics use the limiter to define different inputs, different sections in your input. This is to prevent prompt injections. Ask for structured data like HTML or JSON. Check whether the condition is satisfied and check the assumptions to do the task, as well as the hmm, let me see if I can recall that. Yeah, few shorten prompts, meaning provide successful examples to the model to do the task, and then let the model and then ask the model to perform the task. Okay, and for this tactic two, or for the principle two, like give the model time to think, is well much like the same as human works. So when you ask a person to do a complex math uh, questions without giving the without giving time to work out on the solution first, so it is likely to give you an incorrect answer. So, for example, if you're getting an incorrect prompt or an incorrect conclusion from the model, try to reframe that with a series of steps uh, or a chain of reasoning. So, the tactic one is provide a series of steps, okay, or specify the step to complete the task. Okay, so step one, step two, step three. So find out if there is an instruction in this particular paragraph, or yeah, find out if you can extract here instruction from this paragraph. Let's say a recipe to make a cake. Okay, and then if you do that, well, specify the step to complete the task. The other is instruct the model to work out their solution before rushing into a conclusion. So, for example, when you provide a particular math problem and the student solutions, so instead of copy and paste that, it is more efficient, or it is part of the principle here, that indicate the model to work out the solution from the math problem, compare them with the student, and ultimately say or mention that if the solution is the same as the one performed by the model, and if it is, great. If it's not, well, that's a wrong uh, answer. And also look at the limitations from that. So the model do something called hallucinations. So make statements that sound plausible but are not true. Meaning like describe me, what do you say? So describe describe the new brand Oral B dental floss from McDonald's. So it will give you a very plausible uh, description, but after all, that's not true. This is called hallucinations. And the way to reduce the hallucination is first find relevant information. After all, we're conducting is a research. We are all a consultant. We are all a consultant. After all, conduct a research. So first, find relevant information, then answer the question based on the relevant information. This is to reduce hallucination. So instead of doing that, instead of tell them describe the dental floss from McDonald's, check if McDonald's has this Oral B dental floss. Okay, if it is, then work out the solution on that. But again, this is part of the model limitation, the hallucinations. Okay, okay, cool. So now I'm looking here at the iterative approach.
When I've been building applications with large language models, I don't think I've ever come to the prompt that I ended up using in the final application on my first attempt. And this isn't what matters. As long as you have a good process to iteratively make your prompt better, then you'll be able to come to something that works well for the task you want to achieve.
So this is now the iterative. Iterative. Iterative.
You may have heard me say that when I train a machine learning model, it almost never works the first time. In fact, I'm very surprised if the first model I train works. I think with prompting, the odds of it working the first time is maybe a little bit higher, but as Isa is saying, doesn't matter if the first prompt works. What matters more is the process for getting to prompts that works for your application. So with that, let's jump into the code and let me show you some frameworks to think about how to iteratively develop a prompt. Right. So if you've taken a machine learning class with me before, you may have seen me use a diagram saying that with machine learning development, you often have an idea and then implement it.
Okay, this is from the. Okay, this is from the.
Iteratively develop a prompt. Right. So if you've taken a machine learning class with me before, you may have seen me use a diagram saying that with machine learning development, you often have an idea and
So this is the machine learning development.
then implement it. So write the code, get the data, train your model, and that gives you an experimental result. And you can then look at that output, maybe do error analysis, figure out where it's working or not working, and then maybe even change your idea of exactly what problem you want to solve or how to approach it, and then change your implementation and run another experiment and so on, and iterate over and over to get to an effective machine learning model. If you're not familiar with machine learning and haven't seen this diagram before, don't worry about it. Not that important for the rest of this presentation. But when you are writing prompts to develop an application using an LLM, the process can be quite similar, where you have an idea for what you want to do, the task you want to complete, and you can then take a first attempt at writing a prompt that hopefully is clear and specific and maybe, if appropriate, gives the system
And this is when writing prompt. When writing prompts, it is uh,
hopefully can then, where you have an idea for what you want to do, the task you want to complete, and you can then take a first attempt at writing a if you're not
not the
familiar
prompt.
with machine learning and haven't seen this diagram before, don't worry about it. Not that important for the rest of this presentation. But when you are writing prompts
Mhm.
to develop an application,
Which is this: when you're writing, so when you're writing prompts to develop applications
using an LLM,
using an OMM, OMM. Wait, what? OOM in prompting. Out of memory management. What the hell?
prompts to develop an application using an LLM,
Using an LLM, exactly. Using an LLM. So what the hell? Okay.
the process can be quite similar, where you have
hmm So when you're writing prompts to develop application using an LLM, the process quite be or the process is quite similar. Yeah, the process is quite similar to the machine learning development. To the machine learning development, which is you got an idea, you prompt that, you write that prompt, you get your results, you perform an error analysis, and then you adjust based on that.
have an idea for what you want to do, the task you want to complete, and you can then take a first attempt at writing a prompt that hopefully is clear and specific and maybe, if appropriate, gives the system time to think. And then you can run it and see what result you get. And if it doesn't work well enough the first time,
Yeah,
then
analyze
you
why it does
iterative
not give
process
the
of
desired
figuring
output,
out why the instructions,
refine
for
idea,
example, were
and
not
repeat.
clear enough or why it didn't give the algorithm enough time to think, allows you to refine the idea, refine the prompt, and so on, and to go around this loop multiple times until you end up with a prompt that works for your application. This too is why I personally have not paid as much attention to the internet articles that say 30 perfect prompts, because I think there probably isn't a perfect prompt for everything under the sun. It's more important that you have a process for developing a
hmm Andrew Ng mentioned that it is more important the process.
perfect prompt for everything, 30 perfect prompts, because I think there
Three perfect prompts.
attention to the internet articles that say 30
Yeah, and
perfect
you
prompts,
mentioned
because I
that it's
think
more important
there
the
probably
process
isn't a perfect prompt for
rather
everything under the sun.
than
It's more important that you have a process
perfect
for developing a good
prompt.
prompt for your specific application. So let's look at an example together in code.
Hmm.
I have here the starter code that you saw in the previous videos. I've import OpenAI, import OS. Here we get the OpenAI API key, and this is the same helper function that you saw as last time. And I'm going to use as the running example in this video the task of summarizing a fact sheet for a chair. So let me just paste that in here. And feel free to pause the video and read this more carefully in the notebook on the left if you want. But here's a fact sheet for a chair with a description saying it's part of a beautiful family of mid-century inspired and so on. Talks about the construction, has the dimensions, options for the chair, materials, and so on. Comes from Italy. So let's say you want to take this fact sheet and help a marketing team write a description for an online retail website. Let me just quickly run these three, and then we'll come up with a prompt
Hmm.
as follows. And I'll just paste this in. So my prompt here says, your task is to help a marketing team create a description for a retail website or product based on a technical fact sheet, write a product description, and so on. Right? So this is my first attempt to explain the task to the large language model. So let me hit Shift Enter, and this takes a few seconds to run. And we get this result. It looks like it's done a nice job writing a description, introducing a stunning mid-century inspired office chair, perfect edition, and so on. But when I look at this, I go, boy, this is really long. It's done a nice job doing exactly what I asked it to, which is start from the technical fact sheet and write a product description. But when I look at this, I go, this is kind of long. Maybe we want it to be a little bit shorter. So I have had an idea. I wrote a prompt, got a result. I'm not that happy with it because it's too long. So I will then clarify my prompt and say, use at most 50 words to try to give better guidance on the desired length of this. And let's run it again. Okay, this actually looks like a much nicer short description of the product, introducing a mid-century inspired office chair, and so on. 5 view, just, yeah, both stylish and practical. Not bad. And let me double check the length that this is. So I'm going to take the response, split it according to where there's spaces, and then print out the length. So it's 52 words. It's actually not bad. Large language models are okay, but not that great at following instructions about a very precise word count. But this is actually not bad. Sometimes it will print out something with 60 or 65 and so on words, but it's kind of within reason. Some of the things you could try to do would be to say use at most 3 sentences. And let me run that again. But these are different ways to tell the large language model what's the length of the output that you want. So this is 1, 2, 3. I count 3 sentences. Looks like I did a pretty good job. And then I've also seen people sometimes do things like, I don't know, use at most 280 characters. Large language models, because of the way they interpret text, using something called a tokenizer, which I won't talk about, but they tend to be so-so at counting characters. But let's see, 281 characters. It's actually surprisingly close. Usually a large language model doesn't get it quite this close. But these are different ways they can play with to try to control the length of the output that you get. But let me just switch it back to use at most 50 words. And there's that result that we had just now. As we continue to refine this text for our website, we might decide that, boy, this website isn't selling direct to consumers, it's actually intended to sell furniture to furniture retailers that would be more interested in the technical details of the chair and the materials of the chair. In that case, you can take this prompt and say, I want to modify this prompt to get it to be more precise about the technical details. So let me keep on modifying this prompt. And I'm going to say, this description is intended for furniture retailers, so it should be technical and focus on materials products are constructed from. Well, let's run that. And let's see. Not bad. It says, coated aluminum base and pneumatic chair, high quality materials. So by changing the prompt, you can get it to focus more on specific characters, on specific characteristics you want it to. And when I look at this, I might decide, at the end of the description, I also wanted to include the product IDs. So the two offerings of this chair, SWC110, SWC100. So maybe I can further improve this prompt. And to get it to give me the product IDs, I can add this instruction at the end of the description, include every 7-character product ID in the technical specification. And let's run it and see what happens. And so it says, introducing a mid-century inspired office chair. Shell colors, talks about plastic coating aluminum base, practical, some options, talks about the 2 product IDs. So this looks pretty good. And what you've just seen is a short example of the iterative prompt development that many developers will go through. And I think a guideline is, in the last video, you saw Isa share a number of best practices. And so what I usually do is keep best practices like that in mind, be clear and specific, and if necessary, give the model time to think. With those in mind, it's worthwhile to often take a first attempt at writing a prompt, see what happens, and then go from there to iteratively refine the prompt to get closer and closer to the result that you need. And so a lot of the successful prompts that you may see used in various programs was arrived at an iterative process like this. Just for fun, let me show you an example of a even more complex prompt that might give you a sense of what ChatGPT can do, which is I've just added a few extra instructions here. After the description, include a table that gives the product dimensions, and then format everything as HTML. So let's run that. And in practice, you would end up with a prompt like this, really only after multiple iterations. I don't think I know anyone that would write this exact prompt the first time they were trying to get the system to process a fact sheet. And so this actually outputs a bunch of HTML. Let's display the HTML to see if this is even valid HTML and see if this works. And I don't actually know if it's going to work, but let's see. Oh, cool. All right, looks like it rendered. So it has this really nice looking description of a chair, construction, materials, product dimensions. Oh, it looks like I left out the use at most 50 words instruction. So this is a little bit long, but if you want that, you can even feel free to pause the video, tell it to be more succinct and regenerate this and see what results you get. So I hope you take away from this video that prompt development is an iterative process. Try something, see how it does not yet fulfill exactly what you want, and then think about how to see how this video is and see what
So
results
prompt
you get.
development.
So I hope you take away from this video that prompt development is an iterative process. Try something, see how it does not yet fulfill exactly what you want, and then think about how to clarify your instructions, or in some cases, think about how to give it more space to think to get it closer to delivering the results that you want. And I think the key to being an effective prompt engineer isn't so much about knowing the perfect prompt, it's about having a good process to develop prompts that are effective for your application. And in this video, I illustrated developing a prompt using just one example. For more sophisticated applications, sometimes you will have multiple examples, say a list of 10 or even 50 or 100 fact sheets, and iteratively develop a prompt and evaluate it against a large set of cases. But for the early development of most applications, I see many people developing it sort of the way I am, with just one example. But then for more mature applications, sometimes it could be useful to evaluate prompts against a larger set of examples, such as to test different prompts on dozens of fact sheets to see how its average or worst case performance is on multiple fact sheets. But usually you end up doing that only when an application is more mature, and you have to have those metrics to drive that incremental last few steps of prompt improvement. So with that, please do play with the Jupyter.
So he describing that for the early development, okay. So for early development, okay. So for early prompt development, okay. So for early prompt development, Andrew and Jean mentioned that an iterative process. Try something, analyze where the result does not give what you want, clarify instructions, give more time to think, redefine prompts with a batch of examples. Okay. So far, early prompt development, iterative process. So try something and exactly. So the iterative process is, well, try something, analyze what the result does not give what you want, clarify the instructions, so give more time to think. Following is the second principle. Give time, so give the model time to think by specifying is the step to complete the task, and or let the model work out the solutions before rushing to a conclusion. So, or instruct the model to work out a solutions before rushing to a conclusion. This is part of the iterative process. Okay.
The code notebook examples and try out different variations and see what results you get. And when you're done, let's go on to the next video where we'll talk about one very common use of large language models in software applications, which is to summarize text. So when you're ready, let's go on to the next video.
Okay, one large summary text. It's one of the
There's
used.
so much text in today's world. Pretty much none of us have enough time to read all the things we wish we had time to. So one of the most exciting applications I've seen of large language models is to use it to summarize text. And this is something that I'm seeing multiple teams build into multiple software applications.
You can do this in the ChatGPT web interface. I do this all the time to summarize articles so I can just kind of read the content of many more articles than I previously could. And if you want to do this more programmatically, you'll see how to in this lesson.
Okay.
So with that, let's dig into the code to see how you could use this yourself to summarize text. So let's start off with the same starter code as
With the
you saw
same
before
startup,
of
right?
import
Say
OpenAI,
the
load
same
the API
setup.
key, and here's that get completion helper function.
And this
I'm going
helper
to
function.
use as the running example the task of summarizing this product review. Got this panda plush toy for my daughter's birthday who loves it and takes it everywhere, and so on and so on. If you're building an e-commerce website and there's just a large volume of reviews, having a tool to summarize the lengthy reviews could give you a way to very quickly glance over more reviews to get a better sense of what all your customers are thinking. So here's a prompt for generating a summary. Your task is generate a short summary of a product review from an e-commerce website, summarize the review below, and so on, in at most 30 words. And so this is soft and cute, panda plush toy loved by daughter, bit small for the price, arrive early. Not bad, it's a pretty good summary. And as you saw in the previous video, You can also play with things like controlling the character count or the number of sentences to affect the length of this summary. Now, sometimes when creating a summary, if you have a very specific purpose in mind for the summary, for example, if you want to give feedback to the shipping department, you can also modify the prompt to reflect that so that it can generate a summary that is more applicable to one particular group in your business. So, for example, if I add to give feedback to the shipping department, and let's say I change this to start to focus on any aspects that mention
The shipping and
shipping
the
delivery of the
delivery.
product. And if I run this, then again, you get a summary, but instead of starting off with Soft and Cute Panda plush toy, it now focuses on the fact that it arrived a day earlier than expected. And then the store has, other details then.
Exactly.
Or as another example, if we aren't trying to give feedback to the shipping department, but let's say we want to give feedback to the pricing department. So the pricing department is responsible for determining the price of the product, and
To
I'm
give
going to
feedback to
tell
the
it to
pricing department
focus on
responsible for determining the prices of
any
products.
aspects that are relevant to the price and perceived value. Then this generates a different summary that it says, oh, maybe the price may be too high for a size. Now, in the summaries that I've generated for the shipping department or the pricing department, it focuses a bit more on information relevant to those specific departments. And in fact, feel free to pause the video now and maybe ask it to generate information for the product department responsible for the customer experience of the product, or for something else that you think might be interesting to an e-commerce site. But in these summaries, even though it generated the information relevant to shipping, it had some other information too, which you could decide may or may not be helpful. So depending on how you want to summarize it, you can also ask it to extract information rather than summarize it. So here's a prompt that says your task extract relevant information to give feedback to shipping department. And now it just says product arrived a day earlier than expected without all of the other information, which was also helpful in a general summary, but less specific to the shipping department if all it wants to know is what happened with the shipping. Lastly, let me just share with you a concrete example for how to use this in a workflow to help summarize multiple reviews to make them easier to read. So here are a few reviews. This is kind of long, but here's a second review for a standing lamp, need a lamp for my bedroom. Here's a third review for an electric toothbrush. My dental hygienist recommended. Kind of a long review about the electric toothbrush. This is a review for a blender when it said, so it's that 17-piece system on seasonal sale, and so on and so on. This is actually a lot of text. If you want, feel free to pause the video and read through all this text. But what if you want to know what these reviewers wrote without having to stop and read all this in detail? So I'm going to set review 1 to be just the product review that we had up there. And I'm going to put all of these reviews into a list. And now if I implement a for loop over the reviews. So here's my prompt. And here I've asked it to summarize it in at most 20 words. Then let's have it get the response and print it out. And let's run that. And it prints out the first review is that Panda toy review, summary review of the lamp, summary review of the toothbrush, and then the blender. And so if you have a website where you have hundreds of reviews, you can imagine how you might use this to build a dashboard to take huge numbers of reviews, generate short summaries of them so that you or someone else can browse the reviews much more quickly, and then if they wish, maybe click in to see the original longer review. And this can help you efficiently get a better sense of what all of your customers are thinking. All right, so that's it for summarizing. And I hope that you can picture, if you have any applications with many pieces of text, how you can use prompts like these to summarize them to help people quickly get a sense of what's in the text, the many pieces of text, and perhaps optionally dig in more if they wish.
Mm.
In the next video, we'll look at another capability of large language models, which is to make inferences using text. For example, what if you had, again, product reviews and you wanted to very quickly get a sense of which product reviews have a positive or a negative sentiment?
Exactly.
Let's take a look at
Summarizing
how to
and
do that
inferring.
in the next video.
Summarizing and inferring.
This next video is on inferring. I like to think of these tasks where the model takes a text as input and performs some kind of analysis. So this could be extracting labels, extracting names, kind of understanding the sentiment of a text, that kind of thing.
So if you want to extract a sentiment, positive or negative, of a piece of text, in the traditional machine learning workflow, you'd have to collect a label data set, train a model, figure out how to deploy the model somewhere in the cloud and make inferences. And that can work pretty well, but it was just a lot of work to go through that process. And also for every task, such as sentiment versus extracting names versus something else, you have to train and deploy a separate model. One of the really nice things about a large language model is that for many tasks like these, you can just write a prompt and have it start generating results pretty much right away. And that gives tremendous speed in terms of application development. And you can also just use one model, one API to do many different tasks rather than needing to figure out how to train and deploy a lot of different models. And so with that, let's jump into the code to see how you can take advantage of this. So here's a usual starter code. I'll just run that. And the motivating thing is
Okay, so that'll be all for this video. Take care. Bye bye.